Okay, we are going to continue with cone penetration test plus, okay, the chapter number 2, in situ soil testing. I think we did previously, we started this cone penetration test, but we didn't finish it, okay? And actually, this video also will not finish it. Last time I said we will do it in 2 videos, but actually it's longer than that. So we will do it in 3 videos instead. Okay, so this is the second one, and another one will come to finish it up. So let's continue. The effect of poor water pressure. Okay, water, because we consider that, okay, in many cases, almost all cases, the pore are filled with water. So what is the effect of water in this CPT test? Okay, so due to the inner geometry of the cone, I will show you something. The geometry of the cone itself, the ambient water pressure acts on the shoulder behind the cone and the end of the friction sleeve. You will see an illustration soon. So this effect of is referred to like a unequal end area effect. So this figure, I think you remember these different sizes of cones. And if we go inside the geometry of the cone inside, note that this is normally should be here, okay? So we just make it like this so that we can see clearly what is inside, okay? This cone is just, you can see it here, this head, okay? And this white part, this white ring ceiling, okay, this is where the connection between this sleeve and the cone is made. So the thing is, between here, the connection you can see here between the sleeve and the cone, we have here what we call U2. That means the pore water pressure is measured here, but here also, okay, you can see the beginning is here and the end is here. Okay, that is what it said here. Yeah, the shoulder behind the cone, that is here, shoulder behind the cone, okay? And the end of the friction sleeve, the end of the friction sleeve is here. And this is maybe the road, connecting road, connected to here. So in soft clay, for example, and silt, and in over water work, the measured cone, you remember the cone resistance, it must be corrected for this problem, the pore water pressure, acting on the cone geometry. You remember this figure? This is the cone resistance, sleeve friction, and pore pressure, okay? So this measured cone resistance, it should be corrected due to the pore water pressure, okay? And we are going to explain you how to do that correction, okay? So the corrected cone resistance, QT, the cone resistance is QC. The corrected cone resistance is QT. Sometimes it's called total resistance. The T stands for total, okay? So here is the formula. Corrected cone resistance is equal to cone resistance, the measured one, the one that is directly measured, plus U2. U2 is just here in front of you, the measured pore pressure, okay? And here we have 1 minus A. What is A? Okay, A is net area ratio, okay, which is can easily be determined from lab calibration with typical value between 0.7 to 0.85. Okay, there is a very important thing you should know. In sandy soil, these two are the same. Q3 and Q3 are same. Okay, that means in sand, you don't need to correct the cone. If you are sure that your soil is sand, it will be same. The correction will be same. You will see it. Okay, the measured one and the corrected one are same. So I will explain a little bit more about this effective and the net area ratio. What is the net area ratio? If we take this like our cone, see this? This is our cone. It's same like this one, right? This, with different sizes. So the thing is, the area, the section, or the projected area of the cone, okay, which is same here, AC, cross-sectional area, AC, the area of this cone, okay? This is like outside. And this is represented here also. AC is, in this case, about 1,000 square millimeter, okay? And with this diameter. If we, can you imagine seeing this cone from the top, okay? If you see it from the top here, from the top, you will see this, okay? This inner circle and the cross, okay, is this part. Okay? The small area is the area of this part. Okay, so you can imagine this. We have cross sectional the out. We will call this one the total area, which is here. Okay, that is when you see the cone from down. If you see it from top, you can notice this one, but you can just say the cross sectional area of this part, this one. We will call that one the net area. Okay, so we have total area AC and net area AN. Okay, so the small a which is here is just AN divided by AC. That's all. The net area divided by total area. Okay, so if you want simply just the cross-sectional area of this part divided by the cross-sectional area of this one. Okay, yeah. So then QC, this is, we did this one last time. The capital Q means it is like force in Newton or kilonewton divided by area. Then you get it in Pascal or kilopascal. Okay. So anyway, the corrected cone is just the corrected cone resistance is the measured cone resistance plus this factor, this coefficient. Okay. I hope you understand how this A is obtained. So anyway, depending on the cone you are using, please check what is the value of A. It should be even given in the manual. Okay, so let's continue. So a similar correction should be also applied for sleeve friction. This friction also due to the power pressure. Here is the correction for sleeve friction. The total or corrected corrected friction. As you can see, this one, Fs is the measured, and we have to correct it. Okay, Fs can be obtained from this formula. Okay, Fs, what is this one? This is the measured sleeve friction. Okay, simple. U2 is this one, the measured pore pressure, okay, at the base of sleeve here, this one too, because you have three here. Actually, the one is here, U1 is around here, okay, but we didn't mention that. Okay, U3 is this one, the measured pore pressure, the top at this end of the sleeve, this sleeve friction, okay. AS, you know that is here, the area, total area, surface area of the sleeve. This means the total body of the sleeve, this part, or everything, the total area of the sleeve, okay, around the body, okay. And this one, base, is here at the bottom, B as bottom, and the cross-sectional area of this bottom. You can see it here, okay, this. And this one, B, AST, the cross-sectional area at the top, they are not same, okay? Continuously, as you can see, even here, the shape is changing. Sometimes it is not same, but in some norm in America, for example, you will see that we have to, the cone has to has, these two should be same. This one should be equal to this one, but it is not always the case, okay? So this is what I was saying now. This one in the American standard norm, okay? American Society for Testing and Material standard, we have to get these two should be same. This one should be equal to this one. It means this cone has to, the both NF and the upper one and the bottom one, the cross-sectional area of the cone should be same, okay? So these are just information for you to read. In the case of the 15 square centimeter, this code, this one, okay? The AS is larger compared to these two, okay? In that case, don't forget that these are two. In that case, the correction is small because this is very large compared to these two, okay? These are just information for you. You can just read it, okay? Yeah. Here also, just some information for you. Please read them. Like in offshore industry, okay, we have very deep water. So sometimes we the cone is filled with oil, because if not, the outside pressure will be too much. So the oil will help a little bit to make it equal to the hydrostatic pore pressure. Okay, just information, you can read them. There is nothing to explain, so you can read. Okay, we are going now to see some definition that will help us a lot. I will put this figure here because if the rest of the chapter will depend on the definition we will give. And in all the following definition, sigma V0 is total stress, total overburden stress. Sigma prime V0 is effective stress. U0 is equilibrium pore pressure. Not this one, it is different. This one is pore pressure. It can be excess pore pressure or anything like not normal, not equilibrium pore pressure. Okay, so this one is equilibrium, and this equilibrium pore pressure is just obtained depending on the water level. This is what you know. Uh, I think you know how to calculate. If you have the unit weight of water, which is known, and the water level, you can calculate this one at any depth. Okay, same here also, the overburden stress, effective and total one. Also, if you